the actual mistakes, that's the actual cost.
Give me just a few more minutes to. Brian just gave me his video camera, and I didn't have time to test it out yet. So, if you okay. There we go. I'm like, I am not broadcasting myself. No. Hello.
It's got a lot of interesting stuff. It even has this line following. Using the OpenCV that's just in trend. Like instead of using RGB values, use HSCP values.
There we go.
This section. What?
Okay.
Select linear. So you don't want to go speed. Okay. So it's pretty new. Starts figuring out. Good. It goes into some depth and yeah. I haven't got to it. It was $50. Yeah, I bought it from Amazon.
I'm saying, is it paper or is it?
Oh, paper, yeah. I still keep, Kindle doesn't work for me. I don't know. I just need paper. I have a Kindle and I've read some stuff on it, but it's staring at the screen. It costs a lot extra now to buy the regular books. Plus, they mess up the diagrams and stuff.
For your audio, how will your audio get?
Yeah. It's interesting. Nobody expects nobody to. Mostly. Yeah. I try to read them off PDF.
Would you mind moving that more towards you?
Oh, this?
Yeah.
Okay. Or my facing it just this way?
Alright, I'm giving you.
Oh, okay. So you're trying to line up the the screen. Yeah, it's gonna pop it. It keeps falling. Or if we can. Does that bend? Yeah, that does.
I have no idea. He's sick of watching us.
There it goes.
Kind of in my head.
Okay, are you going to stand about there?
No, I'm gonna be there because I need to use
I
my
put the
computer
down.
to demo.
Okay.
I'm also trying to record as well.
Okay, if maybe
But it
when you
would just be
introduce
the
yourself, you can be there just so people can see you, and then they can see your slides. Would that work out?
Okay. I don't have a slide. It's just for right now.
Oh, you don't have, it's just you?
Yeah.
And the demo. Yeah. Well, there will be something display, but it will be the demo. Yeah.
So should we
Right,
point the
right.
camera
I know,
towards
I know.
you, or, okay.
Do you want? Should I move? I can. I'm in the way here.
Oh, it's okay, but you
Okay.
can just help, right?
Okay.
It's all good. Let me just, people are now texting me. Have we?
And you are listening.
I need, I'm sorry. Nice to meet you. Yes. So, real quick, just there's a lot on the page that I cannot use. Could you want to
What?
Yeah, that might be better than I say stuff about myself. Right?
Let me introduce you. Is there anything else besides what's on the?
Stealing.
The last paragraph, I think.
Microsoft
that's
quiz,
okay.
kind of bust in.
That's
Okay.
it, yeah.
Thank you for doing this.
No problem.
All right.
My pleasure.
All right.
But one can be on at a time, so once you off, I'm on.
That's a good one.
Okay, yes. All right, we'll get started in just a couple more minutes. We are getting the camera set up, and a few people are running late who are texting me and trying to get up here. So we're going to accommodate the fact that there's been a few accidents on the road, apparently, slowing people down. So give us, maybe like 4 more minutes.
Is there someone down there to let them up?
I am seeing. Are you offering to go down there? That would be great. Thank you.
That is Nathan Reynolds, a very nice guy, my colleague. So this is Vegas, everything is rich, okay? And so is that. For you guys. So. And Ryan may have stolen some from me.
Okay. Yeah.
Does anyone?
That was all I had. Let's actually explore and see whether.
Oh, I love using the Titanic in my class as an example.
Are you guys doing a Skype? Or is there a broadcast?
There is a Google Hangout. It's also on YouTube, and the links are on our Meetup page.
Okay.
Do you want to?
I've got a guy that wants to be here, but he's not making it.
That would, if he can get on, the person who's supposed to be testing it can't get on for a couple minutes, so see. Do you have the link? Can you get to the Google Hangout?
I'll go find
I
it.
mean, the Meetup?
I'll go find it.
Okay, perfect. Otherwise, I'll give you a lot of caps and lower cases and fun stuff.
You been working with the guy?
No, I'm just talking to him. He's interested in doing so.
All right. I just got confirmation that the technology is working, so we're good. So those of you who may have friends or connections that are want to go online, there's a link to the Google Hangout and to the YouTube live streaming on our Meetup site, so that you can find the link there. As soon as I can find your information, I will introduce you. What's your PhD?
Oh, computer engineering and computer science. Yeah, in this there.
This is one of my friends got a job at a hospital that I won't, that I won't name, but
Computer science.
I guess I'll tell it.
We can speak and
Yeah, sounds good.
after, yeah.
All right. Why don't we go ahead and get started? Really appreciate everybody coming out on this rainy, dreary, wonderful evening for a meetup, right? So I appreciate it. So I'm Leslie McIntosh. I'm one of the founders of the Meetup, and very proud to say we're almost at 900 members if the last time I checked. So it's very exciting. We consistently have about 50 to 75 attendees. We now have, because we're broadcasting this, we have a group over in Illinois who are watching it. So a shout out to Beth and her gang over there who are broadcasting and watching it in a coffee shop, I think. I can't remember the name of it, but they're over there. And then the new location. So it's very exciting to be here. A couple of announcements. One is that we have another talk next month, and I'll talk about that at the end, but we will not have anything for June and July. Usually we do a training or some sort of hands-on for June and July. And I'm actually going on sabbatical, and my husband, who was the co-founder, will also be gone as well. So we just decided we're going to take a break, and we'll come back in August with most likely a hands-on training demo, something like that, and then we'll get started again. We have some people lining up for the fall, so that should be pretty exciting. So tonight, I'm very excited to have Microsoft sponsor this. It was actually quite nice to have all the pizza ordered by someone else and all of the refreshments. So thank them. I don't know if someone from Microsoft is going to say a word or two, or you just, no, just a hello, or
What is
think. I didn't know if someone was going to.
Yeah, I can introduce them later.
Okay, perfect. Sounds great. So tonight we're going to have Kay speak about Azure, Microsoft Azure. I always say it that way, so you'll have to correct me if I pronounce it incorrectly. So Kay is pretty exciting to me because she has her PhD in computer science and also got an award from the American Medical Informatics Association, which I thought was pretty exciting, which, although you don't do anything with medical informatics anymore, is that correct?
Right.
Okay. Plenty of experience at Centene. Noticed if you read on what was posted in her bio, within the first 2 months of working at Centene, she used data science and machine learning to reduce the mistakes in cash reserve estimations by more than $1 billion. So that's just,
Right.
right? That's exciting, and maybe.
that was a low-hanging fruit.
Right. And what I was telling her earlier is one of my friends got a job at a hospital that I won't name the name of, but it's amazing because within the first month, she was able to able to find something that saved them $4 million. And it was simply by looking at data, and they weren't looking at data before. And you can talk more about your experience if you have a chance. But I think it's very exciting what you've been doing. You have over 15 years of experience with data science, so we're very excited to have you. So welcome, Kay.
Thank you. Thank you so much. Thank you for being here. Thank you, Leslie, for the introduction. And so just a little bit of logistics. If you have not been here before, the bathroom that way, so walk out and go around. And welcome for food and drink, questions. How do I have like an hour?
Oh, yeah.
Okay. So I'm going to do demo today, so just walk you through step by step. And not really any PowerPoint presentation or anything like that. And so before I introduce my colleagues who are having dinner right now, give them some time. So the sign-in sheet wasn't perfect, so we might circulate the sheets one more time. We would like to get email addresses from you guys because we are cooking up another bigger event that we're not sure yet that it will be a public event or our customer event focus, but it will be a full day. And it will talk all about the Azure Cortana intelligence suite, not just Azure ML, not just the machine learning piece. It will talk about all the things on the cloud. And so we are building that, and so would be nice to have the email addresses so that we can send you guys once we're ready. And so now I give you some time to digest your food. So some of my help are very nice to volunteer to help me today. So thank you very much, Thomas Abraham back there. He is also another data scientist and also a solution architect. And he works here in the St. Louis office as well. And so thank you so much. And Brian Murphy, solution architect as well. Brian Roberts, solution architect. And Nathan Reynolds, have you guys got in, right? Get in. Thank you so much. And Pat, Mark Saker over there, thank you for your help, solution architect. So architects are just a quick thing for you before we jump to there. Kind of like for my definition, Microsoft 2.0, as in we don't sell, we build solutions so that we build a long-term relationship with you guys. And so hopefully that, you know, our work in the future will prove that this definition is kind of true. And so like I said, well, it can't be Vegas anymore because of this. I want everything to stay in this room, but anyway, I'm gonna use Google Chrome. My phone is Android. And what else that is not Microsoft? But we are pretty open. If you Google search or Bing search Microsoft Love Linux, you will see our CEO standing next to this thing that's, so a lot of things kind of become more friendlier and friendlier. So that's a nice thing, and that's precisely a reason that I joined Microsoft, because of this move. It's a nice progress, so that a lot of good technologies, why we have to draw a line and say, this is my limit, this is your limit. Why don't we work together and build better solutions for everyone? And so this is an exciting time. And I don't ever remember the website to the software. So I always Google search Azure machine learning, and I'll go there and I will show you from there. So that would be the page that most of us will see first, and you can do free accounts, start it up, and a new exciting feature that we asked the product engineer for a little while. And when I first introduced to this tool last year, we didn't have this, and now we do, which is the deployment part for the free trial account. And so that's a thing. There's some limitation of how many transactions you can run, but at least you will get the experience of the deployment and the web service. So that's a nice thing. So I would say it's a full feature for even free trial account. So I encourage you to try. And after today, you might see the thing that I see that is easy to use. And it also can be as savvy as you like. And it's also help model management, deployment in really quick, rapid time. So all the things that I already said in my abstract, that hopefully you agree with me. And so that's how we're going to go there. If you have your laptop, you can go there as well, but it might take you a few minutes to sign up. And so before, and you can take a tour, and it will walk you through step by step, similar to what I will show you today within an hour or less. A very basic project that will predict something, 2-class prediction. And so that's a nice way to do. And before I jump into anything in here and build and do a demo, I'd like you to know what I'm going to do for today's demo in the example. I'll use this Just one more time, Titanic data set, please. It's Thomas's idea. Good or bad, give him the credit. And so the Titanic data set that we will use will be a clean version of Titanic data set so that we don't have to spend time cleaning missing data, transform any columns or anything like that. But I will show you the features that you could potentially expand this experiment further in the future on your own. But before that, let me, you know Titanic, right? But this is something interesting, so I'd like to show you just a portion of this video because the video is not about Titanic only. It's about the tool called Sandance, which is in Microsoft Research. It's an improvement over Power BI. You show relationship while you changing from one graph, one visualization to the next. But that's not the point of today's talk. Just want to give you the portion of Titanic.
Data set.
5 minutes.
I'll show you. This is the data set of the Titanic survivors. Now every point here is representing a person that was on the Titanic. Let's actually explore and see whether the age-old adage of women and children first was actually followed when they were going to the lifeboats. So here are all the women, here are all the men, and one of the things we can do is we can color it by whether they survived or not. Color might survive. I'm going to choose a palette that makes it a little bit easier to remember that. So I kind of like to use red versus green just to show when they survived. And it helps to have red being died and green being survived. So now you can see that most of the women survived, sorted them by color. And you can see that if we just selected the survivors and just isolated those, you can see about the same number of women as men survived. But as a percentage, you can see that the women did much better. But that's still not the whole story. If we now look at this by cabin class, you can see first
Sorry, need to make myself away.
class, second class, third class in the crew, where there were clearly a lot of people in the crew, and a lot of men in the crew that did not survive. So I'm actually just going to throw the crew out of this and just look at the passengers. And you can see that for just the passengers in first class, only about 6 women didn't survive. And only about 13 or 14 women in second class didn't survive. But in third class, more than half of the women survived. So it helped the female and rich to survive the Well, what about children? Let's look at the age of children. Turns out, similar pattern. In first and second class, there's only 1 person that didn't survive. But in third class, more than half of the kids did not survive. It's kind of interesting. We can actually take a look at this point over here and see who this person is. Turns out it's Miss Helen Lorraine Allison. And if we look her up, there's an entry about her in the Encyclopedia Titanica. And we can find out that she was traveling with her mother and father and brother, and they were separated. And they vowed not to leave without the others. And they were last seen together smiling on the promenade deck. And so it's nice to be able to help associate real people with these data points. You know, one last thing that you might kind of be able to have a story in this, let's take off fasting by class. And let's look at the Titanic by how much the tickets cost. So now I'm going to color this by cabin class. And let's choose a nice qualitative color thing so we can see this well. And I think this one better. So you can see that first class is red, second class is blue, and third class is green, which means they paid a lot less money and they're all over here. Except for this one outlier. Again, the outliers tend to be what's really interesting to me. Who is this person that didn't pay much money but ended up in first class? Turns out it's Mr. Franz Olaf Carlson. Again, we can look them up. Turns out that he was essentially got his captain's papers. He was first mate on our ship. There was a strike. So the company gave him a first class ticket back to New York on the Titanic, but he did not survive the sinking. So he was a doubly unlucky person. So again, this is all about seeing these insights, finding insights, and communicating these insights. And it's really remarkably easy to use. Thanks.
All right. I think my music also playing. Too many things. Okay. So so that's probably one of the things I know you guys Well, I don't. Let me ask. How many people here have been doing data science for more than 5 years? Less than 5 years. Never. So, how many of you are data owners and would like to utilize data science, machine learning to understand your own data set? Good. Thank you. How many of you heard about Azure machine learning before? To this announcement and everything. Oh wow, good. When I first heard about it, I was like, where was I? Like, this tool is really good. How many of you know and use R, the programming language? Python, something else to programming at all? Okay. All right. SAS. Yeah, I started my, like, if it's like chronological order, it would be SPSS, now some other name, IBM, Clementine, or whatnot. SPSS, SAS, Stata, I think, R, and a little bit of Python. So, and I quit being data scientist before. I'm better at Python, so I blame that thing. So, thank you for sharing your about a little bit about yourself. And so, so a trick that, for an example that I wrote in my abstract that Leslie mentioned about Centene and the billion dollars that we saved, was because I tried to be one with my data. And so something like this would help, totally help. Being an outsider data scientist going in to just, utilizing your expertise in machine learning with the data that you don't really know, sometimes it doesn't work. So you just gotta explore and do some of the manual and plot some graphs. And maybe you guys are more like me. I don't like to plot graphs because that is really difficult to make it nice, understandable. And it came from a lab where I got questioned a lot by my advisor, like, what do you mean by this? What is this, label and the colors and things like that? And so I, try to be very careful when I present something like reporting or dashboard. And so, but really understanding the data. And for example, this tiny data set, I did not participate in the Kaggle competition. Somebody in this room might.
In the Kaggle?
Yes, yeah, competition for the tiny. They really spend time feature engineering. They're not only looking at this many columns that the data set gave us. They actually went to do some more research. Say, how far is this room that this person survived or did not survive from the sea level, and build that one more column, for example. These things, and the crew, how far from the gate, where the engine that this guy working and things like that. Just to because it's really hard as some of the crew who survived. But why? How about the 99, 95% the rest did not survive? So the outliers and things like that are really difficult to find, an accuracy kind of a model that can build very accurately. So that's I guess the winner were more like that. People who got to the more accurate result were more like that. And so the data set is not really complex. We can take a look at a little bit. This is one of the things that the engine behind is Azure ML, and they would build a web app on top. And every time you hit, to query this, it will just go to the API web service and just hit the already built predictive analytics model, and it will just send back the answer that it thinks the value in the input here that you give. And so just, survive, not survive, first class, second class, third class, gender, how many children or parents together in one column, how many siblings, how much you paid for your ticket, things like that. So not really a lot of information there, but we can use that today to for our demo. So let's start, right? Okay. So once you if you have gone through signing up process, you can come here and start your experiment. You can load your own data set here too. And just load from local file. You can link this to Amazon Web Services providing, Amazon Web Service, you have to have another module. I will show you. But this one is load from local file and can be a lot of file types, CSV, TSV, plain text, things like that. Zip file, R objects, things like that. And so let me do an experiment. And I'm not going to load any data set. I already loaded that. So you get a blank page that is a drag and drop in nature. So hopefully this is easy enough and to kind of navigate. But there's some trick to it that you have to kind of get used to some terminologies that they pick to use instead of the other terminology, such as scoring instead of predicting. That's another thing. So many of the terminologies that you need to get used to, but there are a lot of blocks, examples, gallery example that are already built, and you can just go in and modify. So that's another nice thing. So I will just go first, right? To predict anything, you will need to load the data. And so the data loaded, and then we just pull it in, and it will be my own data set. So I will pull this one in. And I will just right mouse click to visualize. And you will see all the data just like kind of gut check, sanity check whether the data type is correct. Age should be numbers. Give some basic visualization. And so if you do this and you couple it with survive, it will become a box plot. Give you some idea that it's not a good variable to determine who survived or who did not survive. So, and it's only 2D. So, and you in real life you can go so far as 3D, right? So, more than that, you just get really confused and you might walk back to the future, something. So that's the data set. So we use most of these as our input data, and this one will be our class that we will learn and predict, right? Learn the pattern from the input data, and we will predict according to our knowledge on this data set. So 0 means did not survive, 1 means survive. So that's it. And this one, let me make sure that it's categorical, okay? So that's really important. You don't want to confuse the model. And this kind of problem is called classification, because we have classes to classify. So similar to this, if this, the outcome variable that you want to learn, you want to build pattern from this input data and learn to build this. If this outcome variable is number, what would be the type of problem? Because this will help you to pull the module from Azure ML. If this is number, like money, how much money you make, for example, what would you call this kind of model?
Regression.
Regression, yes. So the other type of problem would be clustering or outlier detection. There's another possibility to find answers from data set. So, it's going to be classification. So we go. And we have 2 classes. So basically, we just do the search here. Or you can just go browse from group by group. Data transformation, which we will skip today, but it has all that you would need to do in terms of project columns, get rid of missing values, impute missing values, all kinds of stuff. Just the terminology that might be a little, so you would say filter and you would say project, so it's a little bit kind of strict to the relational model kind of idea, I think. It can impute with median, mean, just the normal stuff, or learn a pattern and impute missing values with a pattern. So it can do that. Feature selection, it can do that. and can do some of the descriptive statistics. So all of this you can browse here, as much as your heart desire. But we're gonna do 2 class. Prediction, because we're gonna predict survive and not survive, right? Is this too slow, too fast?
Good.
Okay. So we have a bunch of models to choose from, and there's a cheat sheet for Azure Machine Learning. Go Bing search, Google search, and it's a PDF file that will guide you through which one is best for what situation, which one is faster, which one is slower but better accurate. The accuracy is better. So, and for here, I just learned recently, so I've seen this for a while now, and I just got curious fully recently, so that's my bad. Forest jungle, I know random forest, and I use that, and that was one of the best one when I used SMT. The one that saved the money was General Boosted Machine, GBM. It ran quite a while, but the accuracy was the best. But anyway, Forest is also one of the top, but it's pretty slow. So I'm curious how come Microsoft has Jungle, and inside here is all native from Microsoft Research. Also reference the academia, they're already out there published, but we have to implement that on our own to become our own software. So all this is not R or anything like that. Otherwise, it wouldn't scale on the cloud, right? Because this is the point, so that when you deploy, you can hit it with 100,000 transactions at a time. It would run for you very quickly. So this runs on the cloud, can scale, and doesn't limit to the memory like R, but you can extend it with R at the same time in your project. And so the point of this is that they created an improved version of Decision Forest, because some of them can be collapsed, some of the nodes, some of the branches can be collapsed together to save space, hence increase the speed. So I think we're going to use this one today. Even though the data is not very big, but why not? Since we know that it's better than the original random forest. So I'm just going to paste some things here, and then I'll connect them later on, kind of give you the idea. And then, so you can see that this cannot link together because both of them give output. No one take an input from anyone. So the thing is, the architecture of Azure ML say that it will have this function called train model. That is a generic thing that will learn from data by using any algorithm that you plug it into there, and will learn according to the column of the output that you specify for it. Hence, the 2 input ports, and then we will give some parameters there. So the model, you see the green and the red, you cannot put in the red. So that's really helpful, right? And I will go there, and it will, it's not good yet, it's not good yet. So that's the idea. But I'm not going to do this because this is a cheating thing, because you put all the 100% of the data into the training, and then what? There's no more Titanic people. Like there's no more cancer people for me to test. If you use everything, you have to save some. So this is not a good practice in machine learning. That you have to be fair, right? So we're gonna split the data into 2 sets. One set is for training, and one set for testing that we would not touch in trainings, just to be fair. So that you can keep this set all the time. If you change from 2-class decision jungle to 2-class neural network or whatnot, and compare which one is better. Because it's all about experiment. There's not a one best algorithm all the time. So we go there first, take a little detour, right? And then the parameter will pop up there. 50-50 you want? Let's put more on the training, because I kind of want my model to be good. 70% train and 30% test. And random seed is just something that make the random not really random, because you can repeat this random next time. So you can put 0 or anything, just a fixed number. So I'll do 1, 2, 3. And just remember this, so that the 70% will have this same randomness, and the 30% will have the same randomness. 0 is fine too. So now I think we're ready to go give the 70% first to the train, right? And then what is test? Really no test. So we're just gonna score, which is predict. And I'll go back to the red thing later. Score. And then I'll give the data to score. Just like that, always green or red. Red is not something you can give to. So far so good?
Yep.
So far so good? Okay, and then to score, you need the model that you built to score. Not only the data. Right now we gave it the data, we need the model. So we're just building all this. We haven't run anything yet. We can run at this point as well, but we need to fix this red exclamation first because we haven't told it. What is the goal of this learning? So we're gonna learn survive, right? That's the goal. And everything else we just keep. If you don't want to keep them, you can exclude them here too. But we're just gonna learn from everything. I already excluded like ID, ticket number, things like that, because to the best of my knowledge, no logic went into creating ticket numbers. If I had known, okay, ticket number means go to male, go to female, I would keep those. But that's pretty random so far. So, and we can run right now. It would take just a little bit. So the overhead is just, connecting to the cloud. It's not running on your machine. So it's talking to the data center and all kind of stuff. So for the big benefit that would show for this tool would be very big data. So for this size of data, it doesn't seem like, okay, this makes sense. But the thing that already run will not run again next time. So at least it remembers that much. So far so good. And
Okay, there's a question.
In your Titanic preprocessed, how did it know, was that at .csv?
yeah, I loaded as a .csv file.
How did it know survive was a categorical label? Why did it think it was an int or just a number?
I believe this is what I did. So I downloaded the original Titanic dataset, which is a CSV file, and then I opened it in Excel and make sure all data types is what I like, and then I save it as CSV, and then I upload to here. But if it's not correct, you can do metadata editor to change the data type as well. Yes. And there's example that's really full of the Titanic data set that's out there in the blog that I will show you that you can follow. It's a very good question. Yeah, because the survive or not survive are already encoded into 0. It could have been just survive spelling out, and did not survive as well. So had it not been categorical, right? This one that we are talking about, categorical, that's what we want. Had it not been, because these are numbers, 0 and 1, we could pull in metadata editor in, and it would detour to here first, to go here, and then you would tell what column. It wouldn't take too long. We want to change. You can select all the columns of the same type that you want to change at the same time, and do this again and again for each type. So suppose there's only one number you want to change to categorical, which is survive. You do that, you want to change to, all these types that are available, which probably everything that we would need. That's it. And then feed this into the split data. That's it. And you can have as many of metadata editor as you need. Take a look at the score model before we summarize the accuracy and deploy. And that's it. And see the deployment. So we score with the 30%. Okay, 267 rows. How many rows total do we have in the data set?
854.
Really? Who said that? 854, really? You like swung? Because I didn't know. I didn't know. Let me see. I'm gonna give you the whole pile of those things that I stole. Okay, so 30% roughly. Okay, so that's the data. So this will show row by row the result of prediction. So this is the ground truth, the key answer key for you to check whether your model made a good decision or bad decision, wrong decision. And all of this still the input data set, the input columns. And this is the decision that the model made. This is far, I'm sorry, that is not next to each other. So this row think that this person survived with the threshold 0.5. So when it thinks that it's likely that 90-something%, I would say survive. You know, the cutoff is 0.5. It's just a normal thing like other decision making. So this row will say not survive. And so we'll go back and check. 1, 0, so that's correct, right? 1, 0. And you wouldn't want to go through this. You do use machine learning because you don't want to go row by row. You want a summary of the whole thing. So the next one is that we will do is evaluate. Just give you like a curve or something to summarize the whole true, positive, and things like that. That one. Just bring that in. I think this is it. And we need to run. And hopefully we don't run out of green stuff because that's what we made a change in metadata and the link thing a little bit. Maybe it triggered that. Okay, done, not too bad. So that will give a summary of overall prediction, of this graph. The receiving something curve. ROC curve. It came from signal processing a long time ago. The faster you go from the bottom to the top, the better. So if you have 2 models, I can show you 2 models and you will plot 2 lines and you can pick the best one. So that's how this goes. And sometimes it crosses, so you have just to make a gut decision for that. So here it goes pretty fast at first, and then kind of like not really the peak is not really high. So the accuracy in summary is 87%. That's not really great. I'm probably pretty tough. I cannot make this decision if I'm to look at the data myself. But so, and this is something to play almost like if you know that most people survive, so you want to make it easier to make a decision that is going to be survived for this each row. You make it easier like that. So just adjust the true positive, which is survive, predicted as survive. Was this true negative? Did not survive, predicted as did not survive. Yes.
To set in the threshold there, that doesn't flow back to.
No, that doesn't flow back.
Can
no,
you change the 50% cutoff on the previous the score?
Not that I know of. Can we? We can go back to the module to change.
Well, what you would do is you would play around with the parameters for the model and try to get to that. So there's a way to vary all the parameters and run the same data across multiple parameters, and then you would sort of say, okay, this is where I want my model parameters to run at. So that would be like in a number of nodes, number of trees, what is sort of the limitation on when you want to break the node. Those kind of parameters you can, there's a suite parameters where you do a range. So we'll test it across the whole range, and then you can actually then narrow it down to what you want. Okay. But it doesn't flow back to what you have.
When we say it cannot do, there's always a way to tweak. That's what I found so far since I worked with Microsoft. When I say this is not supported, and people will work around and it's fine. So when you see 2 input nodes, you can go in and create an XML. Learn there's a blog to teach you to do that. It's a little bit more advanced, but it's not beyond. You just follow the example and get used to it. You can create 3, just like that. You can modify it. So, and if you say, I take 2 inputs, you zip them up into one, the other inputs that you have, input files, 5 of them into a zip file, load into as a data set, zip, and then it will go in and go select each file and zip inside. So that's a lot of workaround. So, and I believe if we dig further, there should be a way to adjust that too. And so just for fun, we still have a little bit of time before we go into the deployment. Just for fun, do another 2 class, something else. Which one do you want? I'm just gonna build another model and just compare. And just, this is really easy and really quick. Just pick one up inside this list for me.
The neural network.
Huh?
The neural network?
I like that too. All right. I might have highlighted too many things. Okay. It's broken now. So we need train model, one more of them. So kind of like the same thing. Let me zoom out a little bit. So, and this is like a snapshot that you can move around and, it's kind of something that people request that. So do the same thing, reuse the same data. Sorry, here. Reuse the same data. It's a little crisscrossing, but you get it. Do the exact same stuff. And survive. And I think we need another score. And we need to test data just the same. Just kind of copy another model. You could do just 5 of them parallel and going to evaluate. And evaluate will help you understand the whole thing, comparing them. But you will not deploy this one because this is an experiment that you do before you decide which one is the best. Once you know, you delete the not so best, so good, and then you have only one, and then we'll deploy. So we'll see. So far, so good. So we haven't even typed in any code, anything at all. At first I was gonna do, so I didn't know you guys too much, and I thought, maybe the more interesting one would be jump into executing R inside here, and then talking through myself with my colleague, like maybe not. You remember when you didn't know this tool? So we will do execute R Python next time. So, okay, it's that. My hand is at the wall, this thing, so I cannot move. So you see the 2 lines and they crisscross. Pick whichever one. I'll pick the blue one. Is that okay? And the blue one, is the original one, is it?
Yeah, the blue one is the one to the left, and the red one will be the input from the right.
Yes. So the blue one is the jungle, that one, but not really one. I would say it's really, up to your gut decision. So that's how we do it, and you can do this again and again and again to pick the best. And you can fine tune parameters in here. There are a lot of parameters to improve your model. How many nodes inside your network you want to add? How many trees inside your jungle? How many you want to replicate the data for each tree? Because it's a jungle, has a lot of decision trees in there. Or you want to do the bootstrapping. You know those things, right? So the random forest in kind of like layman's terms would be, you have a data set, and do you know this already? Okay, you have a data set, large or small, doesn't matter. Typically, you don't have a lot. You don't have the luxuries of having a large data set, and you bootstrap by random sampling with replacement. You take one out, you put it back to the back and do it again, to build a next data set. That is not like that one, kind of like that, but I pull some. So if I have K, I have Leslie, I have Thomas in here, I pull K out, I put K back. I pull again, I might get K again. So it's kind of like simulating the real world data because you don't know that your sample is real world or not. It's a subset of the real world. So you do this 10,000 times. You build 10,000 trees, and each tree quite independent, learning, from the ground up like that. And in the end, it would vote the decision, or it would average the decision whichever way that would be. So that's kind of like that. And actually, there's a little more into it than that to make it, really good. But at the top level, it's kind of like that. And it wasn't possible to be done before, I'd say, 7 or 8 years ago. When you could not run this on a laptop or on a desktop, it was not popular. It was here. It has been here for a long time. But a data scientist couldn't run it with even a small data set because you cannot replicate 10,000 data sets from one data set. And the limitation is that it runs inside the memory only. You can have 64 gigabytes of memory, but at some point you're gonna hit the limit and it will crash. And so that's another thing. Next time maybe we can explore something else besides our open source as well, because we have some other tools, Revolution Analytics that become Microsoft now that can run outside of the memory and in parallel and multi-core as well. And we have the open source that we put back to the GitHub that you can download. It's called Microsoft R Open, a little better than the interpreter that is R Open, and it will be open source and it will support all the packages out there and in the future. So that's another conversation. Okay, let's remove some of this. And I think I have to run it one more time. We're going to deploy, and we're going to see how easy it is to use the model in something like Excel. So that's done. So we can build the pretty web service. Okay, I got it. And this was one of my most painful pain points when I worked in the industry, because I perfect my algorithm so much and it's so good and it's not overfit. It's good enough but not overfit. And then I want to deploy to run with the real world data that's coming in. Software engineers say, I don't know R, I don't know Python, I know Java, I know C#. What do I do? They pry apart everything, rewrite everything to their own language, because there's a gap between the two technologies. I know Java, I know C++, I know R, but I'm not software engineer. I'm hired to be data scientist, and I'm not going to write a program. That's not, So there's this thing that it kind of dilute all of the things that data scientists or machine learning people build into the model. But this one bypass that by building the model right here and encapsulate it inside this web service that will give you the key. And you can put this key in any program, any languages, and it will just call. And this thing resides in the internet. As long as you connect to the internet, you can call. And no longer any data resides with here. It's just a build model. That's it. So from now, it's just reusing the model. So what it did, just kind of like move things around to become input and output. And then we'll run it one more time. We can clean it up. We can exclude some variables, because in the real life, you would not have the survive variable in the input because you don't know that, you want to predict. But I just like to skip that part a little bit to save some time. So you can project columns and skip those things to make it more real world. It's done, right? And then we deploy. So build web service, make all these light blues, two light blues module, run, deploy. That's it. You got your web service. You can do two things, batch or real time. Request response, it builds something mock up as a web app, but don't count on this because it's black and white, no, no moving or anything. But at least you can play with this. Click here and it will predict something on the web. But that's it. So that's one way to do. Just kind of like spark an idea, do something, like this, and it will be an example. Batch. Batch will show you if it's working. We show you example of 3 languages, but you can do more than that. One is C#, one is R, and one is Python, how to call the web service. So you can copy and paste and expand this, add to your code, cleaning, making sure that the error is detected, the data type is good before you feed into web service. Because web service is really pure, really it doesn't have any defensive mechanism for the error right now. And you can open it into Excel.
What would a demo be if everything went perfect anyway? So I've never been one. Right.
Yeah, it'd be hello world.
Right. Hello world. That's it. Exactly. And there's your random forms.
I don't think these are Titanic though. Oh, you mean the picture?
Yeah.
I don't think I ever see Titanic in here. Yeah, that's income data set, but it's the same idea. That's also income data set, I think.
Can you save your workflow or?
Yes.
Okay.
It's already saved and you can manage, you can go back, you can share the workspace. It helps with collaboration. You can share with people you work with. They can modify, of course. They don't add a lot of layers of privileges yet that you can just share. They cannot modify. Right now there are only 2 types. Yeah.
In the workflow question, will it version for you? So that let's say you're developing a model, you change something, you break it, and you will go back about an hour or 2?
No, you have to copy into a new project. That's how it suggested you to do. So, and what else? You can manage web services because in real life, you deploy the web service, somebody depend on it. Somebody somewhere else in some other country might use this app and hit web service to get the prediction result. So the suggestion is you build another one, build another web service, make sure that this is what you like, and you can exchange the key. Use the same key, so it's seamless to the user that they don't feel that you have changed anything, but you improve in internal working of the model.
Is there a copy button? Can I copy that experiment to another experiment so I don't have to recreate it?
I'm usually the one who give people copies, so I don't know. But I think so,
You can
right?
actually go into the browser and just highlight everything, copy it.
Oh, so
Yeah, but at the summary of it, that you will see a bunch of projects. I think they can copy from me that way. Yeah, I don't think it's working right now.
Do you want to just walk us through one of those?
Yes,
The Excel,
yes.
just even though it's not the Titanic?
So I don't think it's gonna come back very soon.
Like the Titanic.
Yeah, right? Female first class survive. Female third class may not survive. So So this one is very similar to the Titanic, kind of like two class, well not kind, it's two class prediction to do income prediction, whether this row of data set is less than or equal to $50,000 or greater than $50,000. It could have been this example, just the same idea. And once you click the Excel sample from the web service page, you can load sample data if you don't have your real world data. So that's just the sample input data in here. And in this one, I clean up the ground truth, the answer key, so just to make it more real world. And then you type the range on Excel, select the range, make sure including everything A1 to 6 there. And wherever your output you like to be, so I'll say O1. I'm not sure if it's going to predict though, because if the web service over there is not accessible, okay, they predict it. So maybe just the front end. So that's it. And so the idea is that for, in your business, you want to do simulation, you want to do optimization, you want to play with all the input values and see the real-time prediction. You can do it here by doing this. And you can just, so this guy, we think he or she make less than 50,000. This is really old data set. So during the time, median pay probably not really high. So we'll make him really rich, capital gain. And it should predict his money now. Oh. What is this person? State government age 39, bachelor degree, not in a family. Too much will make him rich. Capital gain. He became richer. So you can play with this and understand your data better. This one I think I use boosted decision tree to predict. Let me try one more. Because I want to show you the model management. I'm going over 1 minute, so should I end it?
We started a little late. We're a little flexible.
Thank you. So I'll go to the experiments. So these are all the experiments that you can share with people. Let's go there first. Do you still want to see Excel and Titanic, or you want to see model management? Which one? Model management. Okay. So you will add people in your organization. Because this is an enterprise kind of account now, not a free account. So your company has this one, and load the username, the Active Directory in here. So it will allow you to add people in the same set of Active Directory. And so you go to the user, and I added someone in Microsoft. So I can do it again by this one. Invite user, sorry. And you can just type in, what's your email address?
Mine?
Yeah, you're in my same organization.
Thomas.Abraham. What?
The whole thing?
Thomas.Abraham.
That's it. And he will get an email invitation, and he can access the whole workspace. So it's a shared workspace right now.
And it's full privileges to it?
2 types. Yeah, go back to my answer that I didn't finish. One type is user, the other type is owner. User can modify, delete everything, but cannot grant the next user. Owner can grant the next user.
So trust the people you're adding.
Yeah.
Make a copy, a backup. Trust the people.
Well, typically the workflow is that you just create different workspaces, depending on what project you're working on.
Right.
So if you're working on a project with so group, you just give all of them access, and then you just keep creating different workspaces and managing it that way. That way, only the people in that workspace see that data, and people in the other ones don't see the data. So you usually create different workspaces and manage it that way.
So is a workspace just a canvas that she was working on, or does it include the data sets that she can load in?
Data sets.
Data set and much more. It includes other services inside the Microsoft Cloud services as well that we'll link to.
So you can create multiple of those and have certain people.
So when you sign up for the free one, you only get one workspace. So yeah, if you
Can you guys over there hear?
If you have an enterprise account, you can create multiple workspaces. There's no limit. I mean,
So we're looking at one workspace here?
yeah.
Okay.
So if she drops down, you have multiple workspaces, okay?
Yes,
Yeah. So if you drop down the name there,
Okay.
I have
see
two.
multiple workspaces.
And there are 3 engines right now that we deploy to run Azure ML, not all the regions everywhere, only 3 right now. And in the future, we'll do GPU, to do deep learning and things like that. Right now, we have a model or two that is native to do deep learning, but deep learning is really consuming of the resources. So we not allow this shared cloud to be consumed by some linguistic or something that deep learning is good at. So we can just some GPUs, bring your own or things like that in the future. Manage data set, manage train models. You can put description in here, so it will store, you can put accuracy in here as well. Manage web services, and you can see the consumption of the web services, how many transactions in the past and things like that. Because it's the money that you will have to pay. So yeah, but it's dirt cheap in my opinion for per transaction. I think 1,000 transaction is 5 cents, something like that. So it looks in the business world of the long-term relationship, kind of like that. Not just one-time thing. You run 1,000 rows and you leave, and then this wouldn't make any sense. It looks for something that you constantly run in the future, or a website that you have 100,000 people use at a lot of time from different places of the world. Like that.
Is the transaction somebody going in on a published one, like you are deployed one, or is there a fee on designing? While you were designing that, would that be part of your transactions, or it's just after you deploy it? And
after you deploy.
So
when you train, it's called experiment.
yeah, so you're building
Right.
experiments that.
So for that, it's like the seed, per month or something, $10 per month.
Yeah, so
something like that.
when you're in Machine Learning Studio, you pay for, there are 2 things you pay for. One is the seed. So every user pays $9 a month.
Okay.
Well, I'm not sure if it's a month or a year. It's really cheap.
That's an offer.
Yeah, that's an offer. And then every time she hits play or run, there's compute time. So you get charged for that compute time as you're running the experiment.
And then you get charged for transactions after that as well.
Once you deploy, then everything is on the web service. So it never charges back on the experiment.
Oh, okay, all right. I got it.
Once you deploy it, now it's just a whole different service. It's just the web service. It never goes back to the experiment.
You can be a little more savvy by adding your own custom module using R or Python. You can write your own R script. You can write it somewhere else and load it here as a zip file, including with your packages that you customize or out there in the open source. And you can, add it in here. This is not the best editor for R, so they recommend you to use whatever you're comfortable with, RStudio or whatnot. And you can produce graph, ggplot if you know about the R program. And R is actually, this is not a good example for R. It's ugly. R is actually used to produce a lot of cool graphic in like New York Times or the Economist and things like that. So apologize for this ugly graphic. So yeah, black and white. But yeah, you can extend it to be more savvy, or you can use it the drag and drop way, and you don't have to start from the blank slate. Last thing, and then I'm done. You have to kind of remember the keyword a little bit. Corona Analytics Gallery is just a build experiments that will be a starter for you. And it will load the whole project for you, and you can modify, learn from it, delete some note, add some notes from. Sorry, my mouse is down. And you can do, machine learning API by voice, by text, image, and things like that already built for you. IoT, there's some of those. So we can do text analytics. Example. And you can, I think it logged me out, so you can, if I log in, you can load this into ML Studio and it already built for you. And you can customize according to your data set. So it's not a blank slate. Yes, it's actually a model with sample data. So it will work as a sample for you, and you load your own data, replace that sample data set with your own, and and modify the parameters as you like, or you can use whatever is set here as well. So
can you save, like when you're making that workflow and the designer, can you save that as a template and just plug in new algorithms and stuff, or do you have to restart from scratch?
You can save, you can copy, and you can just modify just some few parts. Yes.
Copy the whole thing.
Yes.
You can't just say this is a template.
Yeah, and you can. No, I don't think it's going to be as a template. You can also contribute back to the community to provide inside the gallery for other people to reuse, for other people to pay to use. That are those ways as well. They thought about all this kind of collaboration, crowdsourcing kind of idea. You have some of the API that are ready to use for time series. You just put in the time series data set with all the times of this person and the next, a chunk, several rows for one unit, for one entity again and again. I will plot time series and forecast for you. It's just an API. So that one you cannot modify. Outlier detection already there. Voice recognition already there. So that's it. That's my last thing.
Are there other questions? I don't see any questions coming from the online group.
Oh, yeah, sorry. I'm sorry.
What's a notebook?
Notebook is Python, for Python, because Python users love to see the output that built into the source code and output together into a PDF nice document. So that's one. And we contribute back to open source as well. So it will be .NET, Visual Studio, Python, Notebook in there, and our editor also is there, will run in there, because .NET is very good in debugging. So that's, kind of blended to software engineering and scientists together in one place.
So there's the online version of the notebook, right? So if you click on, actually it does now R as well, Python and R. So it's basically a REPL interface. So you can go in there, you can actually interact with the models that you build in Azure Machine Learning. So say you were working in Azure Machine Learning in the studio that she was in. So you have something loaded there. You can actually interact with that model in Python by going into Notebook. So you could, like, say you have a data set that's in your experiment and you've done some sort of filtering, you want to do something more, you can actually use the Notebook, go back and access that data and do something more advanced.
Before you publish it?
Yeah.
So while you're working with it in the studio?
Yeah.
And whenever you have any question about any module, on the right side, there's a help thing going on. Sorry, this is not the last thing. So there's a help thing going on, and it will bring you to a blog and more to read. So that's the kind. There's some books about Azure ML. That will be like a one-night read. My customer did that. I did that. I didn't think that I would be able to finish a book within one night ever, so I did it.
Is there another question, or did you get it answered with the notebook?
I was just curious what Python modules are in there. I thought I heard that the Anaconda distribution is loaded.
So it comes with whatever comes with the standard Anaconda distro. All those packages come as part. So if you're used with the Anaconda, the Continuum Anaconda one, it will work. And then you can import all sorts of libraries. So there is the ability to import external libraries into here. So there's a separate module for our libraries as well as Python libraries you can import in there. So something that you developed yourself or some other open source that's not in. So I think Azure Machine Learning has over, for our libraries, we have over 300, 400 libraries. But if it's not in there, you can actually import your own. So as a zip file, and you can use that.
Yeah, import it as a data set, zip file data set, and drag it in just like a data set into an execute R module, which would be the next talk, I think. Yeah, and then you can use it just like code, your own code packages.
All right. Well, I think there'll be some time for more questions. You're going to be here for just a little bit and hang around if other people have questions. So thank you so much. Let's give her a
Thank you for not falling asleep.
I certainly learned a lot, and this I think is very exciting for particularly for trying to get people who don't necessarily want to work with the command line or code into being able to explore data, and which speaks to your topic and title of this, which is democratizing data. So giving this insight to more people rather than just the people who understand the code and understand how to get into that. So thank you so much. Really appreciate your insight. I always love to look at the Titanic data, and it's so simple, but it's so much fun to look at. So I thought that was a great example as well. So thank you so much. Thanks for hosting us. Really appreciated that. Thanks for all of you coming out. We will have another meetup, as mentioned at the beginning. It will be May 11th at 6:30 back over on the WashU campus. And that is going to be, Robert Pless is going to talk about what you can learn from billions of images from our planets. If you don't know some of his work, he's done some really exciting stuff with images, including the thing that I find most interesting is what he's done with images from hotels and like hotel.com, and then he'll map that with Craigslist, and he's looking at human trafficking and seeing if he can figure out where those things match up from images on different sites. I'm not sure he's actually going to use that example, but me coming from a public health background, that was a pretty fascinating one of using images. But he has, I think as he put on here, there's a camera that looks at a brick wall, and he's looked at the images over 8 years and has that, and they do a lot of stuff. So it really switches from the discrete tabular data into working with imaging data, which is a very different way of looking at things and different aspects. So I think that's an exciting turn for us next month. So I hope to see you guys there. Again, we'll be back at WashU, but really appreciated coming out here. It was nice to see everyone show up, have a different place. So I think there's still a little bit more pizza. Let's give her one more round of applause. So appreciate it.
You know, if you care to grab any of their freebies, go ahead. Because I didn't, have a game or anything to contest for the prize. So go ahead.